So here we have the series 11 plus 103 plus 1005, and we need to find out the sum to n terms. Now looking at the series, we can say that this is neither an arithmetic series nor a geometric series. But what we can do, we will need to simplify our given sum. So let's begin. So a sum here is given as 11 plus 103 plus 1005, and this goes on. Now 100 can be also written as 10 plus 1. 103 then will become 100 plus 3. Then we have 1005, which will become 1000 plus 5. So we can see the trend here. We can even predict the fourth term, so that will become 10,000 plus 7. So we have to find out the sum up to n terms. Now what we'll do, we'll combine the first term of each of the terms. So that means we have 10 plus 100 plus 1000. This goes all the way up to n number of terms. Then this will be added to the second term of each of the term. So which is 1 plus 3 plus 5. So we have 1 plus 3 plus 5. And this also goes up to n number of terms. Now, the first sum. So this is a geometric progression. That's because our first term, if we consider it to be 10, then our common ratio will be 100 divided by 10. So that's going to be 10. And the second one, this is going to be an arithmetic series. Here, the first term is 1. And the common difference, d, that will be equals to 3 minus 1. So that's 2. Now we can find out the sum of both the two, geometric and the arithmetic series, by using the formula. For the case of a geometric progression, so let's write it down. For a GP, the sum up to nth term is given by a multiplied to r raised to the power of n minus 1 divided by r minus 1 whenever the r value is greater than 1. And in the case our r value is 10, which is greater than 1. And for the arithmetic progression, the sum to the nth term, that will be simply equals to n over 2 multiplied to 2a plus n minus 1 times the common difference d. So let's obtain the respective sums. For the geometric progression, we have 10 multiplied to 10 raised to the power of n minus 1 divided by 10 minus 1. Plus, for the arithmetic progression, the sum will be n over 2 multiplied to 2 times a, so that's 2, plus n minus 1 times the common difference, so that's 2. Further simplification gives us 10 multiplied to 10 raised to the power of n minus 1 divided by 9 plus n over 2 multiplied to, so here we have 2 plus 2n minus 2, so that's going to give us simply 2n. So we have 2 and 2 cancelling out, so this will be n squared. So therefore we have 10 over 9 multiplied to 10 raised to the power of n minus 1 plus n squared. So this is going to be the sum up to the nth terms of our given series, which is 11 plus 103 plus 100,005 and so on.